section 8.1, real numbers. So far, all of the numbers we've talked about have been under the category of rational numbers, and that's any number that can be written as a terminating decimal or repeating decimal, which also means they can be written as a fraction. Now we're going to talk a little bit about irrational numbers. This is any number that cannot be written as a terminating decimal or a repeating decimal. Two characteristics of irrational numbers is, one, there must be an infinite number of non-zero digits to the right of the decimal point. It means it goes on forever. And there cannot be a repeating block of digits. So no repetend. So an example is the number pi. This is the ratio of the circle's circumference to its diameter. It's 3.14159. It goes on forever. Sometimes we approximate it with 22/7 or 3.14, but those are both just approximations. A lot of times when we use square roots is when we get irrational numbers. So some examples are square root of 2. If you put this into your calculator, you get 1.414213 562, and so on. For square root of 3, we get 1.732050808, and so on. Now, something I want you to notice is when we are taking the square root of a number, we are finding what's called the principal square root, which is always positive. So a few applications. When using square roots, sometimes we will get a rational answer and sometimes we will get an irrational answer. So I want you to see the difference between the two. So for area of a square, that formula is A equals side squared. If a square has an area of 25 square centimeters, what is the length of the sides? Okay, so I'm going to write up the formula and put 25 in for A. And in order to solve for A, I'm going to take the square root of both sides. And then S equals 5. Square root of 25 is 5 centimeters. So this one came out to a rational answer. If a square has an area of 12 square feet, what is the length of the side? So I'm going to use the same formula. Take the square root. And we end up with a number that goes on forever. So we're going to round it to the nearest tenth of a yard. Tenth of a foot. Okay, so when we do that, we end up with 3.5 feet. So that was an irrational answer that we rounded. Pythagorean theorem is another place that we end up with some answers that are irrational. So first of all, Pythagorean theorem can only be used with right triangles. We have two sides that make up the right triangle. Those are called the legs. We call them A and B. And then we have the longest side, the hypotenuse, which is called C. They're related by A squared plus B squared equals C squared. You will need to know this formula. So if the legs of a right triangle have measurements 5 inches and 12 inches, how long is the hypotenuse? So draw a picture. So we have 12 inches and 5 inches. You could switch those, just depends on how you drew your picture. These are the legs, so we're looking for the hypotenuse. I'm going to plug those in. 12 squared plus 5 squared equals 2 squared. Well, if you do 12 squared plus 5 squared, you get 169. Take the square root, and here we get 13. Now it comes out to a nice number, so that's a rational answer. Okay, if one of the legs of the right triangle is square root of 2 yards and the hypotenuse measures 10 yards, how long is the other side? And this one says round answer. So let's see, here's our triangle. We'll call this side square root of 2 because it said one of the legs, and the hypotenuse is 10. So we're going to call this leg A, this leg B. The hypotenuse is 10. So I've got square root of 2 squared plus b squared equals 10 squared. Well, here squared and square root cancel each other, so 2 plus b squared equals 100. Subtract 2, b squared equals 98. Square root of both sides, and here we get an irrational answer, so we're going to round to 1 decimal place, and so we get 9.9 yards. Now, the title of this section was Real Numbers. Real numbers are any numbers that are either rational or irrational that can be written as a decimal. The set of rational numbers, we use the letter R, and it's the union of these two sets. So this is a flow chart talking about all the different kinds of numbers we've talked about this year. So real numbers are any numbers that can be written as a decimal. Then it splits into irrational and rational. Irrational, decimal never repeats and never terminates. And for rationals, it does repeat or terminate. Then we became more specific. Integers were the positive and negative whole numbers with 0. Whole numbers were 0 in the counting numbers, and the natural numbers were the counting numbers. So you will have a chart that looks like this on your next test. And first of all, let me show you what these letters mean, and I will write them out. But the first one's natural, then it's whole, an integer. This stands for rational. This is irrational. And this is real. Usually I leave the real column off, but I'm going to leave it on here for now because I believe that's how it is in the homework. A couple little things over here. This negative 1.5 should have a bar over the 5. And this right here is pi. Okay, so we have to decide, is 6 a natural number? Is it a counting number? Yes. Is it a whole number? Yes. Integer? Yes. Rational? Yes, because it can be written as it is a terminating decimal. So it's either going to be rational or irrational, so I don't have to check that one. And it is real. 3.4. 3.4 is not a natural number because that's our counting number. It's also not whole, and it's not an integer because it has the decimal. However, it is rational because it terminates, and it's real. Negative 1.5 is repeating, is not natural, not whole, not an integer, okay, because none of those have decimals. It is rational because it's a repeating decimal, which makes it real. 0 is not natural, it's not a counting number, but it is whole, it is an integer, it is rational, and it is real. Pi is an irrational number, so it's not going to be any of these first ones, and it's real. Negative 7 is not natural, because that's our counting numbers. Whole numbers, not a whole number. Integers was the first one that covered negatives. Rational and real. And one more time, we're going to look at all of our properties for addition and multiplication. These have come up in many, many sections this entire semester. And so I think that it is appropriate that our very last lesson has them in there also. So closure property is when you add 2 real numbers or you multiply 2 real numbers, you get a real number back. Commutative property says if we add 2 Real numbers, a plus b, is the same as b plus a. Same with multiplying a times b equals b times a. Associative property for real numbers says that we can move the parentheses. So a plus and then b plus c in parentheses is the same as a plus b in parentheses plus c. And the same with multiplication. Identity properties. For addition, we can add 0 and it doesn't change the value. For multiplication, we can multiply by 1 and it doesn't change the value. Inverse properties for addition. Every number has an additive inverse. So a and negative a, if you add them together, you get 0. For multiplication, we have the multiplicative inverse, which was the reciprocal. So if you had a, its multiplicative inverse would be 1 over a. Distributive property of multiplication over addition. Remember, we also had over subtraction, and it would work the same way. We just multiply a times b and a times c. Multiplication property of 0 just said when we multiply by 0, we get 0. The last one we did not have before, the denseness property for real numbers, says for real numbers a and b, if a is less than b, then there is always a real number c such that it is between them. So a few examples to show what this means is we know 2 is less than 3. And so according to this property, there's a number between 2 and 3. Well, one of the numbers between 2 and 3 is 2.5. If we had something like 2.1 is less than 2.2, we could always find one in between. So 2.1 is less than 2.15, which is less than 2.2. So all this is saying is, if you give me any two numbers, I can always find another one that is in between them. This concludes the notes for section 8.1. If you have any questions, please feel free to use the Ask My Instructor button. Thank you for taking my course this semester. I hope you enjoyed it.